So I want to take a few moments here to discuss the importance of Bowens reaction series, because really just about everything we know from mineralogy can be summed up in this nice, neat little diagram. So let's talk about the things we can see on this diagram. First, we notice temperature. We have high temperature to low temperature. The next thing you notice, we have our minerals in the middle, and then over here on the side, we have our magma or lava types. So let's talk about our minerals here in the middle. You can see that we have two different groups. We have our discontinuous and our continuous. Our discontinuous series is all of our mafic. So this is all of the iron and magnesium bearing minerals. Our continuous is our felsic. It is all of our silica and oxygen bearing minerals. Now, the reason why we separate this out is because as our lavas start to crystallize, as they start to cool, right, we can predict the way they're going to form minerals. So as our lavas are really hot, if we start here at our hottest, we notice that we start to form olivine first. Olivine is a highly mafic mineral. It is mainly composed of a lot of magnesium with some iron, a little bit of silica and oxygen, but mostly magnesium and iron. Now, the thing we need to think about is when we start to form this mineral, are we changing the composition of the magma? All right, so here I have my magma, and I'm going to start to form minerals. Am I changing it? Well, let's think of this. I'm going to give you an example. Let's say I go to a party, and at the party there's a bowl of Chex Mix. And I like those little rye breads in the Chex Mix. So if I sit down in front of that Chex Mix bowl, I'm probably going to eat out all the rye breads. Now, after I've eaten it, have I changed the composition of the Chex Mix? Yes, right? The Chex Mix is now rye bread deficient. So, we can talk the same thing about these minerals. As it starts to cool, we become more mafic deficient. So, as this starts to cool, we start to get less and less iron and magnesium. So if we really wanted to draw Bowens reaction series, it's really best shown as a Y. And let me shorten this Y up here a little bit. So over here we have our discontinuous side and our continuous side. And really we can almost put a stop here. That's why it's called discontinuous, right? This is one side of the Y. Now, on our discontinuous side, so here we go from high temperatures, so hot, down to cooler. And when I say hot, this is about 1400 degrees, and when I say cool, this is about 800 degrees. Now our first minerals, right, we saw olivine there, right, very, very high mineral. Then we have our pyroxenes and our amphiboles and our biotites. Okay, but no matter what, we're forming those mafic minerals. Now, there's going to come a point in that magma where there's no more or not enough iron and magnesium left to form any more minerals, any more mafic minerals. That's why we call it the discontinuous series. It's going to stop. However, there's plenty of silica and oxygen, right? We saw that we have our feldspars over here, and then we have our muscovite, and lo and behold, we end Bowens reaction series with quartz. Now, if you remember anything from Chapter 5, you remember that quartz's chemical formula is SiO2. So what does this tell you about the composition of the magma at this point? Hopefully you see that it is very felsic. So we start off and we're very mafic. As my magma gets cooler and we start forming all those iron magnesium minerals, it gets more felsic. So let's go back here and take a look, right, at what we see. So here on Bowens reaction series, we see that same thing. The hotter it is, the more mafic it is, because it can hold more of that iron and magnesium. And the more it cools down, we end up with very felsic magma forming quartz at the end. So we can really use this to predict the minerals we're going to see and to understand. So if I find a lava or a magma that is intermediate, well, that tells me its temperature is somewhere in between. It's used up a whole bunch of its iron and magnesium, but it's not cool enough to make the felsic, so it's been there for a little while. So we can really use Bowens reaction series to truly understand what's going on with mineral formation inside of our lavas and our magmas.